Okay, class, this is part 3 of the inequalities video that we've been working on. In this particular video, we're going to concentrate on solving inequalities using adding and subtracting. Okay, so let's see if we can dive right in. In this particular slide, it says when you add or subtract the same number on both sides of an inequality, the resulting statement will still be the same. So when we look at this first statement, we've got -2 is less than 5. That is a true statement. So if I were to add +7 to both sides, we end up with a statement that says 5 is less than 12. And we notice that that is also true. But one of the things that you need to understand about solving inequalities is this last paragraph. It says you can find solution sets of inequalities the same way you find solutions of equations, by isolating the variable. Now, I didn't use this phrase much in class. The phrase that we used was get the letter by itself, which means the same thing. To isolate means to get by itself. Okay, so what we're going to do is we're going to follow those same 3 steps that we worked with solving equations. Get the letters on one side, get the numbers on the other side. We do both of those using add the opposite, and then we solve. So let's look at our first question. Our first question says n minus 7 is less than or equal to 15. Well, just to kind of review, if we had this as an equation, n minus 7 equals 15, the first thing that I would have you do is change your subtraction to addition next to its opposite, okay? Because we know that that helps prevent making careless mistakes because we have commutativity in addition. So our goal is to get this letter here by itself. We want to isolate this variable. So that means I need to get rid of the -7. And in order to do that, we add its opposite. So you would do n plus -7 plus +7 is equal to 15 plus +7. So if I add something to one side, I have to remember I have to add it to the other as well. Now by this point in time, after the last couple of weeks that we've been solving equations, this line right here should just be sure habit. Okay? So now my 7's go away, they turn to 0, and we end up with n is equal to 22. Now this is an equation. It has only one solution. It does not have a solution set, which is a series of numbers or a group of numbers that would make it true. This one has only one number that makes it true. So now, as that previous paragraph said, you can solve inequalities exactly the same way we solve the equation. So in this one right here, I'm going to do the same thing. I'm first going to change subtraction to addition, next number to its opposite, and then I need to get rid of this -7. So n plus -7 plus +7 is less than or equal to 15 plus +7. This right here will be the hardest part of dealing with inequalities because you're so used to writing equations, you're going to change this to an equal sign. Don't do that. Keep the inequality. My 7's go away. We end up with n is less than or equal to 22. So to understand what that means is that any value less than or equal to 22 of n will make this a true statement. Take, for example, one of the numbers that is there is 20. Okay, 20 is less than 22. If I were to plug 20 back into the equation, 20 minus 7 or plus -7 is going to give me 13. Is 13 less than 15? Yes, it is. Now, for inequalities, we have to do one more statement. We've got to graph it. Okay, so we know this right here is going to mean that we're going to have a closed circle on 22. So we'll do a closed circle on 22 because it is less than or equal to 22. The equal part closes it in, and then we need to shade to the left because I need all values that are less than 22 that will make this true. So let's try another one. Okay. So here's another one here. We've got a minus 10 is greater than or equal to -3. Okay, so I'll give you a moment to go ahead and solve this one by yourself. Okay, let's see how you did. Okay, so we'll take this subtraction sign. We're going to change subtraction to addition, the 10 to a -10, and now I need to get rid of that -10. We do that by, again, adding its opposite. So I had a -10, so I add a +10. It's greater than or equal to -3 plus the 10 that we added to the other side, and we end up with a is greater than or equal to +7, because -3 plus 10 gives us 7. Now, if you're still having trouble with those integers, please make sure that you're typing that in on the calculator to check what you came up with as an answer. Now, it says a is going to be greater than or equal to 7, so we come down to our graph, we find 7. Since it's greater than or equal to, we're going to put a closed circle, and I'm going to shade to the right because I need numbers that are greater than 7 to make this true. So if we were to pick a number, let's say we pick 10 because it fits in the solution set. We got 10 plus negative 10, which is 0, and 0 is greater than negative 3, so it does work. Okay, let's try a couple more real quick, and then we'll be done. Okay, so what about addition? We've worked on subtraction, and we know that in subtraction, I change subtraction to addition next to its opposite. Addition is what we like, okay? So we want to keep that, okay? We don't want to mess with that. So we still need to get rid of this positive 11, and we do that by, or this plus 11, by adding its opposite. So D plus negative 11, oh, excuse me, D plus, I was getting ahead of myself, plus 11 plus negative 11 is greater than 6 plus, and we added the negative 11 to it, so I need to add a negative 11 over here. Add it to the same number to both sides. So we end up with D is greater than or equal to, and then 6 plus negative 11 gives me negative 5. Now in this particular example, what they're asking you to actually do instead of graph it is to actually check your answer. So we need to pick a number that belongs to the solution set, plug it in, and see if it works. So one value that I know is greater than negative 5 is negative 4, or negative 3, or negative 2, negative 1. 0 is even greater than negative 5. And anytime you can use 0 to check your answer with, I highly encourage you to do that. So that's what I'm going to do. I'm going to take this 0, I'm going to take a 0, which belongs to this solution set, and plug it back into the original equation. So 0 plus 11 is greater than 6. Is that a true statement? Well, we do the math, and we end up with 11 is greater than 6. Yes, that is a true statement, so it works. Okay, let's try one more, and then we'll be done. Okay, so this one we're going to do the same thing. I need to get rid of this plus 15. So A plus 15 plus negative 15 is less than or equal to 20 plus negative 15. Again, that line now should just be habit. We end up with A is less than or equal to, and then 20 plus negative 15 is positive 5. Again, if you're still having trouble with these integer statements, please do them on your calculator. So now we need to pick a value that is less than or equal to 5. Okay, now never use the equal one to do a check statement. Always do one with the inequality part. So in another number that is less than 5, you got 4, 3, 2, 1, 0. So, but this time let's try another number. Let's try 2, because 2 fits with this solution set as well. So we take 2, we plug it in. 2 plus 15 is less than or equal to 20. Well, we do the math. 2 and 15 make 17. Is that less than or equal to 20? Yes, it is. So we know we got it right. So that's how we solve inequalities using addition and subtraction.